Good morning, everyone. So what we are looking at today is called the 6 trig ratios. So let's look at our FLT. Given a right triangle, we will be able to identify the 6 trigonometric ratios and their relationships. So there are a couple of things I want to point out with this FLT. First, this part here. 6 trigonometric ratios. Okay, what we've been looking at for the past 2 weeks are 3 trig ratios. But today, we're basically going to add on another 3 for a total of 6 trig ratios that we can learn about in this class. All right, now since we've previously learned about sine, cosine, and tangent, we will be able to identify how they are related to the remaining 3 trig ratios, aka identify their relationships. Okay, so it's not completely new. We're literally just building onto what we've been covering the past 2 weeks. All right, so here we go. Before we get into the new trig ratios, we want to have a strong understanding of reciprocals. Okay, so when we look at a reciprocal, we basically just flip the numerator and denominator of any number. All right, so let's take a look at some examples. Let's say we have the number 3/4. All right, let's take the reciprocal of 3/4. So when we do that, we just flip the numerator and denominator to get 4/3. Okay, and that's it. Let's look at a few more. What about 2/9? Well, here we end up flipping it to get 9/2. And what about something like -7/11? Well, we just flip those two and we end up with 11 in our numerator over -7 in the denominator. What about the reciprocal of a number like 5? Well, it looks like it's by itself, but really 5 is in the numerator and it has an invisible denominator of 1. So if we take the reciprocal of that, we end up getting 1/5. Okay, so this idea of taking a reciprocal will be very important for us when we get into the 6 trig ratios. All right, so here we go. Now with the 6 trig ratios, of course, we use a right triangle to find those sides. So let's assume we have this triangle and we have a reference angle here. I'm going to use theta again. Okay, so with theta being there, that's where I can draw my little buddy to help us identify which side is which. Okay, now a lot of us were asking, okay, how do you know where to draw that person? It really just depends on what the problem is asking of you. When they tell you, they basically tell you which angle to look at. Okay, in this case, we're going to look at this angle here called theta. So that's where I draw my little buddy. All right, now once we do that, we went ahead and identified each side. Of course, the hypotenuse is always across from the right angle. And now with the opposite side, again, it's the side that is opposite to where we are standing. So we say this side would be opposite from us. And finally, the last side here, since it's right next to where we are standing, this will be the adjacent side. Okay. Now, understanding the hypotenuse, opposite, and adjacent sides, we then began to use SOHCAHTOA to help us remember how to set up sine, cosine, and tangent. Looking at SOH, that told us that the sine of our angle theta in this case is equal to O, opposite, over H, hypotenuse. Ka helps us remember that cosine of theta is equal to A, adjacent, over H, hypotenuse. And TOA helps us remember that tangent of theta is equal to O, opposite, over A, adjacent. So this is nothing new to us here, right? But now here we go. We can use these three functions to get the other three trig ratios. So when we look at the next three trig ratios, all we have to do is take the reciprocal of each one. The first one here is going to be cosecant. So let me write that one down. Cosecant. And again, we're going to use 3 letters to abbreviate that. We can rewrite it as CSC. So cosecant of theta is equal to the reciprocal of sine, meaning it's just the hypotenuse over opposite. All right. Next, we get the reciprocal of cosine, which gives us secant. So the secant is abbreviated with SEC, and we say the secant of theta is equal to, this time it's hypotenuse over adjacent. And finally, the reciprocal of tangent will give us cotangent. Oops, cotangent. And again, we just take the reciprocal and we're going to use the 3 letters COT for cotangent of theta is equal to adjacent over opposite. All right, so let's take a look at what just happened here. We took each of the 3 trig ratios that we've learned about, flipped each ratio to get the other 3 trig ratios. So the reciprocal of sine is cosecant, which is hypotenuse over opposite. The reciprocal of cosine is secant, which is hypotenuse over adjacent. And the reciprocal of tangent is cotangent, which is adjacent over opposite.